As an energy expert, I see industrial facilities literally bleeding money every single day. And it's almost always because of overlooked, totally fixable boiler inefficiencies. So, in this explainer, we're going to hunt down those hidden leaks in your system. We want to plug them up before you even think about dropping a massive capital expenditure on a brand new boiler. Think about it. If your facility runs steam, whether that's for manufacturing, food processing, or just heating, your system is basically a giant vessel that's constantly leaking cash through these invisible holes. And today, we're going to find them. We're talking about those sneaky energy losses that just silently drain your operating budget while, frankly, generating a ton of unnecessary emissions. Just look at this staggering number right here, 96%. When you look at the total life cycle cost of a boiler, the fuel it burns can represent up to 96% of that overall expense. The initial cost to buy the actual equipment, that's a mere 3%. Maintenance is just 1%. So what does this actually mean for you? It proves that system optimization, not just throwing it out and buying a new one, is where your real ROI lives. So how do we tackle this? Well, we're going to break this hidden boiler money down into 4 optimization zones: tweaking your excess air, capturing blowdown heat, returning your condensate, and stopping distribution heat loss. And at the end, I'll give you a super practical 5-point action checklist to get you started. All right, let's jump straight into Zone 1, optimizing excess air. Now, obviously, fuel needs oxygen to burn. But the holy grail here is what we call a stoichiometric balance. That's the absolutely perfect, ideal fuel-to-air ratio needed for complete combustion. Now, the big mistake operators make? Tipping way past that balance. In the real world, yes, you do need a little bit of excess air to be safe. But when you crank it too high, you're just heating up completely useless nitrogen and water vapor, and then sending all that expensive heat straight out the exhaust. A really good rule of thumb to remember: every extra 1% of oxygen measured in your flue gas wastes roughly 1% of your fuel. And yep, all of that wasted energy literally just goes right up the stack. But there is a brilliant, reliable fix for this. By installing an automatic O2 trim system, you can lock your combustion right onto that sweet spot. It basically uses a heated probe inside the stack to constantly sample your flue gases, and it automatically tweaks the burner's air damper or fan speed. So, even if your steam load or the barometric pressure or your fuel quality suddenly shifts, you stay perfectly at peak efficiency. Let's put some real numbers to this, because the math is wild. Say you've got a boiler consuming 500,000 MMB2 of natural gas a year. If you tune it to drop that excess air from a really sloppy 44.9% down to a tight 9.5%, the combustion efficiency jumps from about 78 to over 83%. In this specific example, that optimization yields an incredible fuel savings of over $130,000 every single year. Honestly, it's no wonder the Department of Energy actually recommends O2 trim for any boiler burning more than $50,000 of fuel annually. Moving right along to Zone 2, heat recovery from your blowdown. So, to stop dissolved solids from building up and wrecking your system, boilers do what's called a blowdown to purge some of that water. But here's the catch: that water is highly pressurized and incredibly hot. If you're just dumping it, you're dumping money. Continuous blowdown heat recovery fixes this. It uses a heat exchanger or a flash tank to capture that discarded thermal energy, and then reuses it to preheat your ice-cold incoming makeup water. If your boiler has a continuous blowdown rate of more than 5% of its total steam rate, you are a prime candidate for this upgrade. And the payback? It's huge. Let's say you're running a continuous blowdown rate of 3,200 pounds per hour. You install a heat exchanger, and you recover about 90% of those energy losses. In a plant paying, say, $8 per million BTU for fuel, getting that heat back translates to a massive $68,000 in annual savings. Plus, as a really nice bonus, cooling down that blowdown water before it hits the drain helps keep you compliant with local codes that literally ban dumping scalding liquids into the sewer. Okay, Zone 3, returning your condensate. When your steam actually does its job and transfers its heat out in your facility, it turns back into liquid condensate. Now, this condensate is hot, usually sitting somewhere between 130 and 225 degrees Fahrenheit. The more of this hot water you can pipe back into the boiler, the less cold makeup water you have to pump in. And since that cold makeup water is usually chilling at around 50 to 60 degrees, bringing it all the way up to boiling takes a huge amount of energy. So reusing your condensate drastically cuts down your fuel burn, slashes the chemicals you need for water treatment, and seriously lowers your sewage disposal costs. And man, these savings pile up fast. Let's say you manage to return just an additional 10,000 pounds per hour of hot condensate back to your boiler. you're looking at saving roughly $34,000 in water and sewage costs alone, plus another $88,000 in fuel energy. That is over $120,000 back in your pocket every single year. It just goes to show how optimizing your water recovery is absolutely tied to your overall fuel efficiency. All right, let's talk about our fourth zone, stopping distribution heat loss. Take a look at the bare equipment we have over here. A super common and frankly massive mistake in a lot of facilities is going all out insulating the main process pipes, but then leaving ancillary stuff like valves, flanges, and fittings totally bare. These exposed metal chunks are basically just radiating heat into the room 24/7. But the fix is so incredibly simple. Custom, removable insulation jackets. They just use draw cords and Velcro, which means your maintenance crew can pop them off in seconds without any tools, do their work, and slap them right back on. Ignoring this is an incredibly expensive oversight. Think about this. Just one single uninsulated 6-inch gate valve running that 305 degrees Fahrenheit is costing you $525 every single year in wasted fuel. Just one. Imagine walking through your facility right now. How many bare valves, flanges, and steam traps do you think you'd find? According to the Department of Energy, throwing some proper insulation on those can reduce those specific energy losses by a whopping 90%. But it's not just about the money, right? Exposed valves are a major safety hazard. OSHA compliance actually dictates that heated surfaces need to be 120 degrees Fahrenheit or lower to protect your team from burns. So, an uninsulated 350-degree valve is a massive liability. But wrap it in one of those simple custom jackets, and you instantly drop that surface temperature down to a completely safe 104 degrees. You keep your workers safe, and you stop the bleeding on your utility bill. Okay, we've covered a lot of ground. Let's move to our 5-point action checklist. Consider this your roadmap for slashing those utility bills and cutting emissions, all without having to buy a brand new boiler. Number 1, tune your boilers and get an O2 trim system installed to lock in that perfect excess air ratio. Number 2, get a heat exchanger in there to recover the thermal energy from your continuous blowdown. 3, maximize every drop of that hot condensate return. 4, insulate every single valve and flange that's running over 120 degrees. And 5, this is a really great pro tip from our sources, install a reverse osmosis or RO unit to pre-treat your incoming water. If you filter out those minerals from the start, you won't have to blow down nearly as often. So, I want to leave you with this final thought today. What are your uninsulated valves and your unchecked excess air costing your facility right this very minute? Seriously, grab a thermal gun, go check your boiler stocks, and just do the math. Because every single day you wait to implement these fixes is just more of your budget sent straight out the exhaust pipe. Get out there, optimize your system, and take control of your energy costs.